hole. One way to make a black hole is through the death of a star. If you have a star that is 20 times the mass of the sun or more, then as that star evolves through its life, it's going to explode as a supernova, and then what's left after the explosion is a black hole. But then there are black holes that are much, much bigger, so 1,000,000 to 1,000,000,000 times the mass of a sun, and those are called supermassive black holes. And it turns out that every big galaxy has a supermassive black hole at the center.
How do they achieve these huge masses? I first thought about was, why can't you just have some galaxy that just has a ton of gas in it and just feed this black hole to make it into this billion solar mass black hole? But those kinds of processes of just directly feeding it, that's not enough material to make it grow to what we observe. So we specifically as a group study supermassive black holes that are often undergoing some sort of large merger between galaxies. And we think that maybe supermassive black holes merging together is one of the contributing factors that could explain why they're so big in the current universe. So we look for what we call a pair of quasars.
So a quasar is a supermassive black hole with this big accretion disk of swirling gas and is really, really bright. So a quasar is like a black hole that you can see when you have a black hole and some gas is being gravitationally pulled towards it. The gas doesn't just fall straight in. Just like if you fill up your bathtub with water and you pull the plug, the water doesn't just fall straight down the drain. It kind of swirls around and then goes in. So same thing happens with gas around a black hole. Gas is pulled in gravitationally, it swirls around, and it forms this thing called an accretion disk. It's just a disk of gas kind of waiting its turn to fall into the black hole. But the black hole is so much mass, you're so close to it, that gas is swirling really fast, it gets heated up and emits lots and lots of light. So that accretion disk can create more light than all the stars in the galaxy combined.
Say you have two galaxies, each with its own supermassive black hole at the center. When these two galaxies merge together, the two supermassive black holes come together and form a black hole pair. The black hole pair then merges together to become one more massive black hole. The galaxy merger itself also creates a huge disturbance of the stars and gas in those merging galaxies. It's like a train wreck of disturbed gas, with a lot of the gas being funneled towards the center of the galaxy and feeding the supermassive black hole at the center. What we're trying to do is learn about how much galaxy mergers can change the way that black holes and galaxies evolve together.
The way that black holes evolve is tightly connected to the way that galaxies evolve. If I was plotting the mass of the galaxy against the mass of the black hole, you would find that this is a tight line, with the mass of the black hole increasing in step with the mass of the galaxy. So to understand how galaxies evolve, you have to understand how black holes evolve.